All right, get ready to dive deep because today we're going all in on bromine.
Bromine.
Yeah, you know that element that's liquid at room temperature, just one of two on the whole periodic table. And we've got a ton of your research right here, a whole stack, a bromine bonanza, and I gotta say, I'm already hooked.
Oh, it's fascinating stuff.
Did you know it gets its name from the Greek word for stench?
Yeah, it's true. Not the most flattering name, huh? But, it speaks to bromine's dynamic nature, I guess you could say. It's an element most people encounter every day without even knowing it.
Hiding in plain sight.
Exactly.
Well, today we're going to shine a light on it, really explore what makes bromine so unique.
We'll uncover its hidden talents, dig into its past, even look at its potential impact on the future, especially with, all the renewable energy stuff these days.
Let's do it. First things first. Where do we even find bromine on the periodic table?
Okay, so picture the periodic table, that big chart of elements. Bromine hangs out with the halogens over in group 17,
Okay.
right between chlorine and iodine.
Ah, the halogens. Known for being, what is it, reactive?
Exactly. And bromine is no different. It's got that eagerness to react, loves to mix it up, but it's the physical form that really makes it stand out. At room temperature, it's this heavy reddish-brown liquid,
Mm.
and it evaporates easily into a gas.
Oh, wow.
Yeah,
So that explains the name then.
precisely.
Yeah.
That pungent, irritating gas. Hence, the name from the Greek word for stench.
Makes sense. So bromine exists, but how did we even discover it?
Well, the discovery story is pretty interesting.
Yeah.
Two chemists, get this, discovered it independently around the same time.
No way.
Yeah. In 1826, Antoine Ballard, over in France, he was studying the residues, the stuff left behind, after evaporating salt water.
Okay.
And that's when he isolated bromine.
It was just hiding there.
Right. But here's the kicker. Just a year before that, Carl Jacob Loeg in Germany, he'd also discovered bromine.
What?
Yeah, he extracted it from mineral water.
Unbelievable. Two different sources, same element.
Talk about a coincidence, right? Great minds think alike, I guess.
Or maybe great minds stumble upon the same element alike.
Yeah, something like that.
So, two discoveries, but who gets the credit?
Well, Ballard, he got his findings published first, so his name is the one typically associated with bromine's discovery.
Ah, the pressure to publish, right.
Right.
Okay, so we know bromine exists. It's got this, let's say, colorful history. But where does it actually hang out in the world?
Yeah, good question.
We're not going to find it in a swimming pool, are we?
No, you're not going to find pools of bromine just lying around. It's actually relatively raw in the Earth's crust. But, and here's another curveball, it's abundant in the oceans.
Really? The ocean. So it's ice safe to swim in.
Yeah, it is.
Okay, good to know.
The concentration in seawater is about 65 parts per million. Not enough to be harmful for a quick swim, but bromine, it really loves to dissolve in water.
So,
It tends to accumulate in places like, have you ever heard of the Dead Sea?
oh yeah, of course.
Yeah, the concentration there is much higher.
So the Dead Sea, it's like a giant bromine reservoir. That's fascinating.
Yeah, and that actually makes extracting bromine for industrial purposes much easier.
Okay, which leads to my next question. How does this element that smells, well, and hangs out in the ocean, how does it impact our lives?
Now that's where things get really interesting, because despite its, let's say, humble origins, bromine is a workhorse. It's got this vital role in a surprisingly diverse range of applications.
Okay, you're going to have to elaborate on that because I am very curious. What's its most surprising role?
Let's start with its biggest role,
Yeah.
safety. Bromine is a key component in flame retardants.
Flame retardants.
Yeah, those often unsung heroes that make our furniture, electronics, building materials, all that, less flammable.
Wait, so you're telling me my couch is secretly protecting me from fires thanks to bromine?
You got it. These brominated compounds, they work by interrupting the chemical chain reactions that fuel flames. Think of them like molecular firefighters, always on standby to prevent a small spark from turning into a major fire.
That's incredible. I never would have guessed that something as simple as my couch could have such a complex chemical backstory.
Right.
But I have a feeling fire safety is just the tip of the iceberg.
You're right, bromine. It's got this knack for popping up in unexpected places. Take photography, for example.
Okay.
Remember those old daguerreotypes?
Yeah.
Those, hauntingly beautiful images from the early days of photography?
Oh, yeah. They've got this, timeless quality.
Yeah, exactly. Well, bromine played a key role in capturing those moments.
Really? How so?
Silver bromide.
Okay.
It's highly sensitive to light, And it was used to create those early photographic plates.
So bromine, it's like the original Instagram filter, but, way more chemically complex.
Exactly. And its historical resume doesn't end there.
Let me guess. It's also got a medical history.
You got it. Bromine in medicine is a fascinating story.
Okay, I'm all ears.
In the late 19th, early 20th centuries, bromide salts,
Okay.
they were commonly used as sedatives and anticonvulsants.
Bromide salts. You know what that reminds me of? Bromo seltzer?
Bromoseltzer.
Wasn't that like a headache remedy?
It was. People used to use it for everything. Headaches, upset stomachs, you name it. But there was a catch.
A catch? What kind of catch?
Well, effective in the short term, sure, but bromide salts, they had some, let's say, unintended side effects,
Like what?
especially with prolonged use.
Okay.
Turns out bromine, in high enough doses,
Yeah.
toxic.
Toxic, like poisonous.
That's a little more nuanced than that. Small amounts of bromide, they're naturally present in our bodies.
Really?
Yeah, and they might even have some beneficial roles.
Huh. So a little bromine is okay.
Right. But excessive exposure, it can lead to this condition called bromism.
Bromine.
Yeah, and that can manifest as skin rashes, neurological issues, whole bunch of stuff. So that's why bromide-based medications, they've largely been replaced with safer alternatives.
So bromine's got this whole other side to it. It's like fire safety hero, photography pioneer, and then, a cautionary tale in medicine.
It's like the resume, right?
It really is. And to think we're just getting started. Speaking of which, remember how we talked about bromine accumulating in the Dead Sea?
I do, yeah.
It's like a giant bromine reservoir, right?
Right. And that abundance, combined with, all the advances in technology, it's opened up a whole new world of possibilities for bromine,
Like what?
particularly in the realm of renewable energy.
Renewable energy. Okay, now that's a curveball I did not see coming.
Yeah, it's pretty amazing, actually.
How does bromine even fit into renewable energy?
So as we transition to cleaner sources like solar, wind power,
Right.
we need efficient ways to store that energy for when, the sun's not shining, wind's not blowing.
That makes sense. You can't always rely on sunshine and a gentle breeze.
Exactly. And that's where bromine steps in.
Okay, I'm listening.
It's a key component in this technology called zinc-bromine batteries.
Zinc bromine batteries.
Yeah, and these batteries, they're great at storing large amounts of energy, which makes them perfect for, smoothing out the intermittent nature of renewables.
So bromine could be essential in making renewable energy more, reliable?
Precisely. It's got the potential to be a game changer in the transition to a more sustainable energy future.
That's incredible.
Of course, there's always another side to the story.
Right. What's the catch this time?
With any powerful technology, we've got to consider the potential downsides, right?
True. So on that cautionary side, what should we be mindful of when it comes to bromine?
Well, bromine itself is naturally occurring. It's the human-made organobromine compounds that raise some concerns, environmentally speaking at least.
Organobromine compounds. Okay, breaking that down, what are those exactly and what kind of environmental impact are we talking about?
Organobromine compounds. Okay, breaking that down, what are those exactly and what kind of environmental impact are we talking about?
Well, they're basically organic compounds, but with bromine added in.
Okay.
And they've got a bunch of uses, but some of them, especially those used in certain flame retardants and pesticides,
Right.
they've raised some red flags about their potential to, deplete the ozone layer.
Wait, ozone depletion. Are we talking like the hole in the ozone layer? But I thought we made progress on that.
Yeah, we have. Thankfully, international agreements like the Montreal Protocol,
Right.
they led to phasing out the most harmful ozone-depleting substances.
Okay.
And that included some of those problematic organobromine compounds.
That's good to hear. So we learned our lesson there
Yeah, definitely.
and took steps to protect the ozone layer.
We did, and it really shows how, international collaboration.
And science, they can come together to make positive changes. But the story doesn't end there.
Of course not. There's always more to the story.
Right. The challenge now is to keep developing and using these bromine-based compounds.
Yeah.
But in ways that, we get the benefits without the risks.
Finding that balance.
Exactly.
So where does that leave us with bromine? It's used in fire safety, photography, medicine, even renewable energy. It's kind of a double-edged sword, right?
Go on to.
Benefits and risks. Sounds like we're still figuring out how to navigate that.
Yeah, you've hit the nail on the head. Bromine's story is a great example of how science and society, they're always evolving together.
Yeah.
As we discover new applications for this versatile element, we also have to deal with the implications.
Right.
It's a constant cycle of learning, adapting, and innovating, really.
It's almost like bromine itself is on a journey of discovery, too.
Haha. In a way, yeah.
Which begs the question, what other surprises does bromine have in store for us?
That's a great question, and one for our listeners to think about, too.
Yeah.
With the demand for flame retardants going up, the push for sustainable energy, and all the advancements in material science, how do you see bromine's role evolving in the future?
That is a great question. It feels like we've only just scratched the surface of bromine's story, and I, for one, am excited to see where this element takes us next.
Me too.
Well, there you have it, everyone, the story of bromine.
It's quite a story.
From the ocean depths to, well, cutting-edge technologies. It's a testament to scientific curiosity and the importance of balancing innovation with responsibility.
Couldn't have said it better myself.